Okay, so today we are doing 3 sections. Okay, I want you to start your Cornell notes. Okay, we are doing Cornell notes. You're expected to do them on a daily basis. Okay, in your subject, you can call this polynomials. Polynomials. You can say order. We're going to add, subtract, and this is section 5.6 through 5.8. So we're going to start with, the first thing I'd like you to do is just write, hold on. Okay, so the first thing I want you to write is the word descend, descending order. Okay? Yes. Okay. So, can I turn this off and go back to the PowerPoint?
No.
Okay, and descending order means going from the biggest exponent to the smallest exponent. Okay? Now, once you finish writing that, we're going to go on to the example, and you're going to put it right underneath. No line, anything, just on the right side. Okay? Can I erase this? So right under those notes, we are going to write our example. Number 1, we're not doing all examples, so don't write them. Please write the first example, number 1. It's negative 9 plus x squared minus 3x to the 5th plus 4x squared minus x plus 5x to the 3rd. Okay? Now, if we're putting this in descending order, or AKA standard form, you should probably add that also in your description where it said standard form, put under parentheses. Where it said descending, put in parentheses standard form. Okay? Somewhere in your notes so that you know descending form is standard form. This is how I'm going to expect your answers to come to me. So in descending order or in standard form, how would we write that? Louis, what would I start with?
Negative 3x to the 5th power.
Good. We're starting with the biggest exponent, negative 3x to the 5th power. What would go next?
Plus 4x to the 4th power.
Plus 4x to the 4th. Notice I'm kind of circling them or crossing them out. Jean?
Plus 5x to the 3rd.
Plus 5x to the 3rd. I'm glad that you're telling me what sign. Keep going. How about Adam?
Minus 9 plus x.
Nope. We're going in standard form, descending order.
Oh, x squared.
Okay. Plus or minus?
Plus x squared.
Plus x squared. Okay. Next, go.
Minus x.
Minus x. And finally, we have, finish it up. Minus 9. Now, minus x is because x is to what power? 1. And 9 is really to the 0 power, but we don't write x to the 0 power because that equals 1, and 1 times 9 is negative 9. So we don't really write this. We also don't write that one exponent, but that's why it goes in that place. Are there any questions? Yes.
So it doesn't matter what the coefficient is, it's just like how big
It's
the
all about the exponent, right? The order that they go in. It's in order of the biggest exponent, right? Okay, questions? Do we need to do another sample here? Okay, so let's move on. Do you have a question?
Would you have to draw a line before the example to separate?
It doesn't matter. You can draw your line now. Let's just write a definition now, right underneath. Okay, you've got your actually I don't need to do that. I can go like this. You've got your Cornell notes, and that's not it. Sorry. Okay, so you've done the example, right? We've got all that. Let's draw another line. And we're going to say ascending order. What does that mean? What does that mean? Go, Alec.
It means you're going from the smallest exponent to the biggest exponent.
Okay, so I'm just going to give you an example, like 5 plus x plus 3x squared plus 2x to the third. Does that make sense?
Yeah.
So we're going from the first to the second to the third with the constant term first. Any questions?
Should we write that out?
Yeah. I did 5 plus x to the first plus 3x squared plus 2x to the third. Okay. Now, okay, so now look at your neighbor. So now I'm going to, okay, so now let's look at the directions here. It says state whether each polynomial is written in ascending order, descending order, or neither. So number 1, let's start with Emerson.
Neither. Oh wait, no, that's descending order.
Descending order because it's to the second, the first, and the 0. Good. This is, he said, descending order. Okay, next one, let's go, Greta.
Ascending order?
Ascending order because it's the 0, the 3, the 4, the 7. Good. And then the last one, Maxime?
Neither.
Neither. Because it's the second, then the first, then the third, then the fifth. Neither. Okay, questions? Yes, we don't need to write that down.
I'm confused on why the last one is neither.
Well, it's not going from small to big. That's 0. That's 1. If you look at them, it's 0, 2, 1, 3, 5. They're banking that you don't know that this is to the first power, right? And then it looks like 2, 3, 5. So we have to read into those exponents. All right, so the next one, I want you to draw a line. Okay, I want you to draw a line. The next line underneath, right? And you're going to write the following 3 things. Notice what the directions are here. We're going to abbreviate these directions. Combine, descending, variable p. So in your directions, it should say, you should have a bullet, combine. We're going to say descend. We're not playing with that. You're writing as we're going. And we're going to say variable p. Okay? And then I want you to write this down. 5p squared minus 3p to the third minus 4p plus p squared plus 5 minus 2p. You understand? Yes.
So when there's just a number that's not like it doesn't have like an exponent or, you know, like a p or an x or whatever, then why is it like...
Let me explain it first. Okay, so now you should hopefully have this problem written down, and we're doing 3 things that are mentioned in your directions. We're combining the like terms, okay? We're putting it in descending order, and we're putting it in order of the variable. I'm going to pause the recording, and I'm going to give a small explanation, and then I'll kind of come back to this, okay? So when we combine like terms, the variable and the exponent have to be exactly the same. So we're going to do 2 steps at once. Number 1, it says they want us to combine our like terms. Number 2, we want it in descending order. So let's go with the biggest exponent. What is the biggest exponent? Jean?
3.
3, right? So what are my terms that I can combine?
Negative 3p to the third,
And
7p to
what kind of 7?
positive.
Good. And so when I put all those p to the thirds together, how many do we have if I have negative 3 and positive 7?
4p to the third.
4p to the third. So what we're really doing is just adding and subtracting the coefficients. Okay? And what would go next? Ethan?
5p squared and p squared.
Okay, we're going to go to the p squareds. So I have 5p squared, positive p squared, and that makes how many p squareds?
6.
Good. And is it positive or negative?
Positive.
Positive 6p squared. Okay, so all we're really doing is adding that coefficient, not the exponents. When we add like terms, we do not add those variable and the exponents. Okay, what would go next, Emerson?
The negative 4p and negative 2p.
Good. Negative 4p. Oh, let's go. Negative 4p and negative 2p make how many p's?
Negative 6p.
Negative 6p. And what would go last, Emerson?
The plus 5.
Plus 5, right? So that is us. We've done it all in one step. We combined our like terms, and then we put it from biggest exponent to smallest. Okay, did you all write this down?
Yes.
Pause the recording if you need to take notes, because I'm about to erase. Can I erase?
Yeah.
Wait,
Yes.
never.
Okay, so I just erased, and I'm going to show you like here. You'll notice that in my PowerPoint, they just combine in any order and then put it into standard form. I think that's too much writing. So do it all at once. Got it? Put it in descending order. Start with your biggest exponents. All right. Now notice on the next one, the directions say combine the like terms in descending order in order for the p. So before I do that, I'm going to make sure I'm showing every exponent, because remember, this term has to look exactly the same variable, the same exponent. Okay, so notice in this second term, n is really to the first power. Everything's been labeled. In the third term, n is to what power? 1, and p is to the first. Okay, in the fifth term, n is to the first and the p is to the first. In the fifth, 1, 2, 3, 4, 5, 6th term, n is to the first, p is to the third. Okay, now we are going in order of the p. Where is the biggest p? Gideon.
The biggest p would be 4p to positive 4p to the fourth.
Good, so that's the first term I write down. And sometimes I just cross it out or I circle it knowing that I used it. What would go next? How about Jean?
It would
Which term or terms?
I'm not sure.
Okay, Louis?
Would it be 3np to the third?
And
And then you would subtract np.
that's right. That's the next set of terms that go because we're going in order of the p's. They would have to tell you in order of the p's if you have two variables or in order of a particular variable. So if I have 3np to the third and I subtract 1np to the third, how many np to the third do we have? We have what? Plus, minus,
+2.
positive 2
NP to the third.
np to the third. Good. So now I've used those two. What would go next? How about Hugo?
The next would be n to the third and p to the second.
Plus n to the third, p to the second. Is there something else to combine that with? No. Okay, I've used that. And what am I doing next? How about Adam?
The np, so
Okay.
negative 2np
And
6np
makes.
makes negative 8np.
Good. Okay, and are we done? Okay, there we have it. So does everybody understand when we have multiple variables? They would have to tell you, otherwise I guess you get to choose it. Okay, questions? All right, moving on. So, yes, Adam.
If it didn't tell you, wouldn't you choose the one that has most, that is like,
The highest degree
well,
polynomial?
there was a p in all of them, but
No, they really have to tell you, okay? All right, draw a line under that. Go back to your notes, okay? And the next thing that, whatever it was that was written there, okay? Okay, so our next part of our Cornell notes, you're going to write evaluate. Okay, we're writing evaluate. And here, what does that mean we do? We substitute. And then we find the value. Okay? That's what should be in your Cornell notes. We evaluate, we substitute, and then we find the value. Questions? Now, under that, I want you to put A equals 2, B equals 3, C equals 4. Maybe it's easier for me to do this. And D equals 5. You're writing this. And then you're going to write number 1, which is, what was it? A minus
No, T minus A before.
T or D?
D.
D minus A to the 4th. Okay? You would substitute in, what is the D? 5 minus A is
2 to the 4th.
2 to the 4th. We always do exponents first. So that becomes a 16. So it's 5 minus 16. And that simplifies to negative 11. Notice I have not added any equal signs. So to evaluate means write the original question, substitute in, simplify down. This is what we call simplifying. We can simplify it to one number, we do. Questions? Okay, do you feel like we need to do more of these? No. Okay, we can move on to the next section. Draw a line, yep. And I believe we're going on to, I'm going to use this as a warm-up. going to pause the recording. Okay, so in your Cornell notes, and I have a lot smaller of a space, but I do expect that you have a decent size. You're going to write add polynomials. I would have it a little wider so you could write, okay? Now, you're going to write down the problem, 4x to the third. You should be writing it now. Go. 4x to the third, and I would say the quantity, plus x squared, minus 5x, minus 7, close parenthesis, plus the quantity of negative x to the third, minus 2x, plus 1. Okay? And you're going to do the work right there. So basically what we're doing is we are just having one polynomial and we're adding another. When you have that addition sign in the middle, if I distribute it, a positive times a negative makes a negative. It makes a negative, and we still have negative 8x to the third. If I distribute this here, it's still going to be negative 2x. And if I distribute this positive times positive, we still have a positive. Did the values change? No. So it's really like we can go right to combining our like terms. What would my like terms be? What is the biggest one? We always start and we do it in Riley.
It would be negative 8x to the third and 4x to the third.
Negative 8x to the third and positive 4x to the third make how many x to the third? Negative 4x to the third. Okay, Amani, what would go next?
The x squared.
Good. Does it combine with anything? No, we're just going to list it. Okay, what would go next, Amani?
Then the negative 2x and the negative 5x.
And that makes?
Negative 7x.
Good. And that becomes what?
Negative 7x.
Good. And then next, let's go with, how about Hugo?
Next is negative 7 and 1, which makes negative 6.
Negative 6. Okay, are there any questions? Okay. Emerson, are you staying present? Okay. So, yeah.
Does parentheses do anything in this case?
Not in this case, not really, but it's just the way they present the problem. They're saying, here's a polynomial, add the other polynomial. Okay? Questions? Yep.
So like, let's say it's so in between the parentheses it will be minus. It would be,
Let me wait till I get there. Okay? Now, there's a way they call it the vertical method. I personally, I think this is very time consuming, so I really don't spend a lot of time on it. Basically, we write the whole first polynomial. Okay? We're writing the whole first polynomial. So here's the first polynomial, and we write it down. Okay? Then, as I write each term in the second one, we're going to line it up. So this lines up negative 8x to the third. This lines up with negative 2x. This lines up with positive 1. Now when I add, we're really only adding our coefficients. So you can see we're only adding the 4 and the negative 8. And that makes negative 4x to the third. The next one, we bring it down. The next one, we're adding negative 5 and negative 2. That makes negative 7x. And then we have negative 7 and 1, and that makes negative 6. Okay. You can do either method, I don't care, but this just tends to be a little bit faster. Okay. Pause the recording if you... Okay, we are now going to move on to subtracting polynomials. Pause the recording if you need to take notes. All right, so next in your Cornell notes, You've got this. We're going to write additive inverse.
Or do it in opposite too.
The additive inverse on the left. On the right, it's going to say the opposite. Or you can write add the opposite. Adding the opposite. Okay? An additive inverse is adding the opposite. Now, the examples you're going to do. Let's write number 1. What's the additive inverse of y? Negative y. Good. What's the additive inverse of x plus 3? What is it? Negative x minus 3. We're just multiplying it by a negative. The whole binomial. Miriam, what would the opposite of t minus 4 be? Perfect. You get the idea? Opposite of 3m squared minus 6. Opposite of 3m squared minus 6. Ford.
Opposite of 3m squared minus. That would be negative 3m squared plus 6.
Yep. So basically that's what we're doing. This is the additive inverse binomial. Okay, so now we're going to go to subtracting polynomials. We can take an additive inverse of a trinomial. It means we distribute negative to each term. Okay? Questions there?
No.
Okay, I'm going to go right to subtracting polynomials because this is mostly pre-algebra. All right, so now I have a polynomial minus a polynomial. So I want you on your Cornell notes, you are writing, right, the next one is going to be, say,
8x.
oh, hold on, it's going to say, whoops. Okay, I want you to do this, and we're calling this subtracting polynomials. Okay, and then you're going to write the problem right here. Okay, and the problem is 8x squared minus 5 minus the quantity of 2x squared plus 4. So the first thing you're going to do, and next to the problem, I want you to write these notes, distribute the negative to the second binomial, right? Or polynomial. So really what they're saying is this whole thing is the additive inverse, and that's going to become negative 2x squared, and this becomes minus 4. And I've got my 8x to the second minus 5. Okay? So I just write the original problem down, which was the 8x squared minus 5. I just bring that down. The only thing I've distributed is that negative in between. Ethan, is that answering your question?
Yeah, so you just rewrite a negative.
Right. Now we combine our like terms. By the way, I'm reminding you, you're getting graded on these Cornell notes. So, what would go first, Greta?
You would subtract the 8x to second minus the 2x to second.
Good. And that becomes
6x to second.
6x to the second power. And what else is there?
Then you subtract the negative 5 and the negative 4.
Good. This one. We can do a line. We can do a box. And that becomes
Negative 9.
minus 9. And we're done. That's all we do. Because a 6x squared will never become a 9. I do not add 9 to it. Am I clear? Okay. Question.
It's a question about something earlier. It was
Mm-hmm.
so when you had it was t minus 4, and then why was the opposite like? So why was that one just negative t minus 4?
It wasn't negative t minus 4. It's negative t plus 4.
Oh.
right? Because to do the opposite, it's negative, distribute it, it's negative t. And here it becomes plus 4.
One that said,
No, it's both signs are opposite,
oh.
okay?
Because then when it said x plus 3, it was negative, like basically negative 1 times the quantity of x plus 3.
Where? Okay, where?
X plus 3.
Okay, they're both negative because when I distribute it, they were both, this is positive, so it becomes negative. This is when I multiply a negative, this becomes negative. They're both opposite.
So you're just rewriting the problem on the first one.
Okay, so now my question to you is, I would like, okay, let me have you guys pause the recording and I want you to try the next one on your own. Go with number 2, pause. All right, now let's check our work. We're going to distribute that negative to the 4k squared, and that becomes negative 4k squared, and that becomes a positive 2k. And then I bring all the other terms down, negative 6k squared minus 3k plus 1. When I combine my like terms, I have negative 6k squared minus 4k squared. That makes negative 10k squared. Negative 3k, positive 2k, that makes negative k. And then I have my positive 1. All right, now my question for you right now, I want you to draw a line under that in your Cornell notes, okay? And we're going to do something different now. We haven't done this yet, okay? So now I want you to come up with your own test question. Give me a question. The question's going to go over here, and I want you to answer your own question here. Got it? Take a minute. It's a quiet time. You're not discussing it. I want you to come up with your own test question for me to add to my test on anything we've learned today. It could be a vocabulary question. It could be a math question. Come up with your own question. It could be like one of the little questions I ask as we're doing. What's the first? I mean, it could be like.
Did you answer?
Yeah. I want on the left side you're asking the question. On the right side you answer the question. Okay. Pause the recording. So over here we're coming up with a test question, and this is the answer. Give me a thumbs up. Yes.
Can you also put the numbers like under each other for subtraction?
Yes. You have to be very careful. Okay, so the question is, can you also, so like let's say I have 2x squared plus 3x minus 2 minus 5x squared minus 6x minus 1. Or actually, better yet, let me just do 2 terms, right? Minus 1. Okay, so if you're doing that, you still have to distribute first. Do you understand? When you're doing it horizontal method, because what's going to go under here is you have to have that, you have to distribute that next part, that negative. You can't just put 5x squared. It would have to be a negative 5x squared, and this is a positive 1. Okay, yeah. Okay. And now we can do it. It's negative 3x squared plus 3x plus minus 1, right? All right. Can somebody give me their test question they came up with? I'll first.
I wrote add polynomials, and then I wrote negative 4x squared, the quantity of negative 4x squared plus 3x cubed minus 9 plus the quantity of 10x squared minus 8x cubed.
I should have more room here, huh? Plus, what'd you say?
Plus 10x squared minus 8x cubed.
Okay, now, usually you would get these in standard form. Is this in standard form? Unless I was asking you to put it into standard form. So what you just have to be careful, because you, the teacher that's grading it now, if you don't say add the polynomials and put them in standard form, then you're going to get it in all kinds of order. It's going to take you forever to grade the test. So we want to say that. All right, we'll finish our question tomorrow.